Good afternoon. Let me introduce my report, the title of which you see on the slide. Okay. A number of chemical compounds have been recently synthesized and brought into industrial circulation, which can inadvertently get into food, straws, packaging, containers, and so on, and pose a potential health hazard has been increased. During the 71st session of the Executive Committee of the Codex Alimentarius Commission, New Zealand proposed draft guidelines for risk analysis of chemical inadvertently present in food at low levels, noting that regulatory documents do not currently cover this group of substances. The inadvertent presence of chemical means accidental contamination of food not regulated by current national or international safety standards in food or raw materials. However, clear criteria for selecting these substances in the draft guidelines were not proposed, but identifying and assessing the potential hazard of inadvertently present chemicals are necessary for further health risk assessment. In the Russian Federation, methodological approaches to detecting and identifying chemical substances inadvertently present in foodstuff have been proposed as a development of the provision outlined in the draft guidelines. The developed methodological approaches include 4 stages: analytical identification of chemical substance, integral assessment of chemical hazard, employing additional selection criteria followed by the application of a score and summarizing of points, categorizing chemical substance with the assignment of potential hazard categories, and final stage, health risk assessment for selected chemicals based on the integrated index. The analytical identification stage can be accomplished by gas chromatography mass spectrometry, gas chromatography mass spectrometry for the identification of volatile organic compounds, pesticides, pharmaceuticals, persistent organic pollutants, and so on. Inductively coupled plasma mass spectrometry or atomic emission spectrometry optical emission spectroscopy for the identification of metals and other elements. Recovery methods, including extraction, oral extraction, solid phase extraction methods, and so on. An inadvertently present chemical detected in a food product is considered potentially hazardous if it meets the following conditions: 90% or higher probability of matching with the mass spectral library with confirmation using a standard substance sample. The presence of identified potential hazardous chemicals in at least 50% of samples of food products or food raw materials of the same type. Availability of relevant sources of information on the possibility of developing adverse effects. For example, non-carcinogenic, carcinogenic, embryotoxic, mutagenic, and so on. Or the ability of the chemical to produce product with higher toxicity than the original substance. It's advisable to use the toxicological characteristics of the identified substance as hazard quotients, for example, lethal dose. In order to identify priority substances, a toxicity score were assigned according to the classification adopted by the Oxford Handbook of Hazardous Chemicals according to lethal dose for oral intake. Also, when assigning the priority of inadvertently present chemicals, criteria are used that take into account the possibility of migration during the cooking of food or the formation of new substances in the product during technological exposure, the possibility of migration from packaging, containers, reservoir, and so on, and the likelihood of their entry into the food product with the raw materials. Each positive answer is assigned 1 point, and for a negative answer, 0 points. Summarizing up the scores according to the criteria we get in integral index. At the categorization stage, depending on the value of the integral index, the potential hazard category, or PHC, of inadvertently present chemical substance is determined. These categories are the basis for making decisions on the choice of priority substances to assess the health risk. The inadvertent presence of chemicals with a high potential hazard in food product is considered a priority for risk assessment. The presented methodological approaches were tested on the example of canned meat for infants, since this product is intended for the most sensitive group of the population. I'm sorry, okay. Yeah. At the stage of analytical identification, the inadvertently present chemical substances in the selected product were determined by GCMS and LCMS. As a result, the identification revealed 20 inadvertently present chemical substances in 15 studied samples of the food product. At the stage of analytical identification, using the selection criteria, the probability of mass spectrum matching with the library was 90%, and the presence of more than 50% of food samples allowed us to identify two groups of compounds that meet the selection criteria, n-nitrosamines and phthalates group. At the integral assessment stage, using additional criteria for selecting priority substances for further risk assessment, taking into the lethal dose, we calculated the integral index and established the category of potential hazard of inadvertently present chemical substances, which you can see on this slide. It was found during the selection of potentially hazardous, inadvertently present chemical substances using methodological approaches developed in the Russian Federation that n-nitrosamines posed the highest potential hazard. They had potential hazard category number 1. The analytical identification of n-nitrosamines was conducted using methods approved in Russia for determined n-nitrosamines in food products, which allow the determination of n-nitrosamines at low levels. The results of a quantitative assessment of the content of n-nitrosamines in canned meat for infant nutrition in Russia and Socialist Republic of Vietnam are presented on the slide. As a result of the toxicological characterization of the substances identified, the International Agency for Research on Cancer found that n-nitrosamine was classified as a probable carcinogen, 6 as a possible carcinogen, and 1 as unclassifiable carcinogen for humans. The non-carcinogenic effects of n-nitrosamines were manifested mainly as liver dysfunction. An analysis of the oral intake reference dose data for n-nitrosamines showed that only 3 n-nitrosamines have reference doses. Target organs and system for the adverse effects of these n-nitrosamines are liver, organs of vision, blood and developmental processes. To assess the exposure of n-nitrosamines consumed with canned meat for infants, Vietnamese and Russian researchers conducted a sociological study and found that the average daily consumption of canned meat varies from 52 to 128 grams per day in the Russian Federation, and from 90.8 to 27.1 grams per day for children in Socialist Republic of Vietnam, depending on age. For health risk calculation at the exposure assessment stage, average body weights of canned meat consumption over 2 years and a half were established. 2 years and a half is exposure frequency. Infants consume special canned meat from 6 to 36 months. The calculation of health risk was carried out according to the risk assessment methodology developed and used by the countries of the Eurasian Economic Union and harmonized with the generally accepted methodology. As a result, lifetime average daily dose associated with carcinogenic and non-carcinogenic effects were calculated. The obtained doses made it possible to assess the non-carcinogenic and carcinogenic risk due to the intake of N-nitrosamines with canned meat for infant nutrition. Assessment of the health risk to infants consumed canned meat for infant nutrition containing N-nitrosamines on the example of products sold in the Russian Federation and Socialist Republic of Vietnam revealed no excess hazard quotient in both territories. However, the calculation of carcinogenic risks has shown that when canned meat for infants sold in the Russian Federation from 6 months to 3 years of age is consumed, a carcinogenic risk may be formed in infants of the corresponding group. This difference between Socialist Republic of Vietnam and the Russian Federation is due not only to the difference in the content of nitrosamines in the examined product, but also to the greater volume of canned meat consumption in Russia. Thank you for your attention.